Hello. Hello and welcome to this video, which is the exemplified read-through of Python standard library. And in last video, we had covered till here. So now we will just read back a bit, that is about fold, so that we have the continuation, and it is important actually. So it can have two values, either 0 or 1, and it is used to disambiguate wall times during a repeated interval. A repeated interval occurs when clocks are rolled back at the end of daylight saving time, or when the UTC offset for the current zone is decreased for political reasons. The values 0 and 1 represent respectively the earlier and later of the two moments with the same wall time representation. So daylight saving time is not observed in all countries. For example, in India, we do not observe daylight saving time. In Europe, they do that. So what actually happens is that when the summer comes, the clock is shifted so that they save electricity on public resources. For example, road lights or lampposts. So for longer days in summer, the clock is shifted. And similarly, when winter comes, it is shifted back. So that's what the fold will represent. And these were the operators we had studied. So we had plus minus of date time with time delta and another date time object. We had equality comparison and order comparison, and note that 1, 2, 3, 4, 5 are the list items of the commentary on this. So we read this. Date time 2 here is the duration of time delta removed from date time 1. So 2 plus, so that time delta is removed from date time, moving forward in time if time delta dot days greater than 0, or backward if time delta dot days less than 0. The result has the same tz info attribute as the input date time, and date time 2 minus date time 1 is equal to time delta after. Overflow error is raised if date time 2 dot year would be smaller than min year or larger than max year. Note that no time zone adjustments are done even if the input is an aware object. The second one, that is we subtract time delta, computes the date time 2 such that date time 2 plus time delta is equal to date time 1. As for addition, the result has the same tz-info attributes as the input time, date time. And note, time zone adjustments are done even if the input is aware. Third one is subtraction of date time objects to date time objects, which gives us a time delta. Subtraction of a date time from a date time is defined only if both operands are naive or if both are aware. If one is aware and the other is naive, type error is raised. Aware and naive means, does it have time zone information? That means aware. If it does not have, it is naive. If both are naive or both are aware and have the same tz-info attribute, the tz-info attributes are ignored and the result is a time delta object t such that date time 2 plus p is equal to date time 1. No time zone adjustments are done in this case. If both are aware and have different tz-info attributes, a minus b acts as if a and b were first converted to naive UTC date times. The result is a dot replace tz-info is equal to none minus a dot UTC offset minus b dot replace tz-info is equal to none minus b UTC offset, except that the implementation never overflows. The fourth one is the equality and fifth one is the order comparison. Date time objects are equal if they represent the same date and time taking into account the time zone. Naive and aware date time objects are never equal. If both components are aware and have the same tz-info attribute, the tz-info and fold attributes are ignored and the base date times are compared. If both components are aware and have different tz-info attributes, The comparison acts as the components were first converted to UTC date times, except that the implementation never overflows. Datetime instances in a repeated interval are never equal to datetime instances in other time zone. Now we look at the order comparison. Datetime 1 is considered less than datetime 2 when datetime 1 precedes datetime 2 in time, taking into account the time zone. Order comparison between naive and aware datetime objects raises type error. If both components are aware and have the same tz_info attribute, the tz_info and fold attributes are ignored and the base date times are compared. If both components are aware and have different tz_info attributes, the time zone acts as components were first converted to UTC date times, except that the implementation never overflows. Now we have looked at the class attributes and methods. Now we look at object attributes and methods. First method is date. It returns date object with the same year, month and day. Then we have time. It returns time object with the same hour, minute, second, nanosecond and fold. tz_info is none. Then we have time tz. Returns time object with same hour, minute and microsecond, fold and tz_info attributes. Then we have replace. So it takes several arguments. Year is equal to self.year, month is equal to self.month, day is equal to self.day, hour is equal to self.hour. So these are the default values and the fold is 0. Returns a new datetime object with the same attributes but with the specified parameters updated. Note that tz_info is equal to none can be specified to create a naive datetime from an aware datetime with no conversion of date and time data. Datetime objects are also supported by generic function copy.replace. Then we have datetime.asTimeZone where tz is equal to none. Returns a datetime object with new tz_info attribute tz, adjusting the date and time data, so the result is the same UTC time as self but in tz's local time. If provided, tz must be an instance of a tz_info subclass and its UTC offset and DST methods must not return none. If self is naive, it is presumed to represent time in the system time zone. If called without arguments or with tz is equal to none, the system local time zone is assumed for the target time zone. The .tz_info attribute of the converted datetime instances will be set to an instance of time zone with the zone name and offset contained from the OS. If self.tz_info is tz, self.asTimeZone tz is equal to self. No adjustment of date or time data is performed. Else the result is local time in the time zone tz representing the same UTC time as self. After as tz is equal to dt.asTimeZone tz, comma, astz minus astz.utc offset will have the same date and time data as dt minus dt.utc offset. If you merely want to attach a time zone object tz to a date time dt without adjustment of date and time data, use dt.replace tz_info is equal to tz. If you merely want to remove the time zone object from an aware date time dt without conversion of time and data, date and time data, use dt.replace tz_info is equal to none. Note that the result tz_info.from UTC method can be overridden in a tz_info subclass to affect the result returned by asTimeZone. Ignoring error cases, asTimeZone acts like. So this is the implementation given. So if self.tz_info is tz, that is the same time zone has been specified, you return self. Else UTC is equal to self minus self.utc offset.replace tz_info is equal to tz. And then we return tz.from UTC and we supply UTC. Then we have UTC offset. If tz_info is none, returns none, else returns self.tz_info.utc offset self and raises an exception. If the latter does not return none or a time delta object with magnitude less than 1 day. Then we have DST. If tginfo is none, returns none, else returns self.tginfo.dst self, and raises an exception if the latter does not return none or a time delta object with magnitude less than 1 day. Then we have tgnum. If tginfo is none, returns none, else returns self.tginfo.tgname self. Raises an exception if latter does not return none or a string object. Then we have time tuple, return a time.struct time such as return by time.local time. So d.time tuple is equivalent to time.struct time, d.year, month, day, hour, minute, second, weekday, year day, and DST, where year day is equal to d.to ordinal minus date, d.year, comma 1, comma 1, to ordinal plus 1 is the day number within the current year, starting with 1 for January 1st. The tm underscore is DST flag of the result is set according to the DST method. tginfo is none or DST returns none. tm underscore is DST is set to -1, else if DST returns a non-zero value, tm underscore is DST is set to 1, else tm underscore is DST is set to 0. Then we have UTC time tuple. If datetime instance D is naive, this is the same as D.time tuple, except that tm underscore is DST is forced to 0 regardless of what D.DST returns. DST is never in effect for a UTC time. If D is aware, D is normalized to UTC time by subtracting D.UTC offset, and the time.struct time for the normalized time is returned. tm underscore is DST is forced to 0. Note that an overflow error may be raised if d.year was min year or max year and UTC adjustment spills over a year boundary. Now we have a warning because naive datetime objects are treated by many datetime methods as local times. It is preferred to use aware datetimes to represent times in UTC. As a result, using datetime.uct time tuple may give misleading results. If you have naive datetime representing UTC, use datetime.replace tginfo is equal to timezone.utc to make it aware at which point you can use datetime.tuple. So we need to remember that what it returns. It returns all this. Okay, all this information is returned by time tuple. It will come handy. Okay. Then we have to ordinal, which we have already seen in earlier videos. Return the proleptic Gregorian ordinal of the date, the same as self.date.to ordinal. Datetime.timestamp, return POSIX timestamp corresponding to the datetime instance. The return value is a float similar to that returned by time.time. Naive datetime instances are assumed to represent local time, and this method relies on the platform C make time function to perform the conversion. Since datetime supports wider range of values than mktime on many platforms, this method may raise overflow or OS error for times far in the past or far in the future. For aware datetime instances, the return value is computed as dt minus datetime 1970, 1, 1 tginfo is equal to timezone.utc dot total seconds. There is no method to obtain the POSIX timestamp directly from a naive datetime instance representing UTC time. If your application uses this convention and your system time zone is not set to UTC, you can obtain the POSIX timestamp by supplying tginfo is equal to timezone.utc. So you first replace the time zone and then get the timestamp. Or you can directly calculate the timestamp. You subtract that date with the 1st January 1970, which is Unix epoch, and then you divide by time delta seconds is equal to 1. Then we have weekday, return the day of the week as an integer where Monday is 0 and Sunday is 6. The same self.date.weekday. We have ISO weekday, return the day of the week as an integer where Monday is 1 and Sunday is 7, the same as self.date.is ISO weekday. Then we have ISO calendar, return a name tuple with 3 components year, week, and weekday, the same as self.date.iso calendar. Then we have ISO format where separator is T and time spec is auto. It returns a string representing the date and time in ISO 8601 format. So this is the ISO format if microsecond is not 0, and this is the format if microsecond is 0. So this is your microsecond. If UTC offset does not return none, a string is appended giving the UTC offset. So if UTC offset does not return, a string is appended giving the UTC offset. So here this will give you the offset, okay, and this will give you offset. So we have example, we import datetime SDT, we construct an object that is 18th of May 2019, time 3:17:08 p.m. and 132,263 microsecond, and we put it in as a format. And here we supply tj info is equal to UTC, and we put this in UTC as a format. So this is your uh, time zone offset. Okay, sorry, this is the time zone offset. The optional argument separator default P is a one character separator placed between the date and time portion of the result. For example, we again import dt, and then we have class tz dt.tzinfo, and we define a function UTC offset, and we take an argument 1 and returns dt.time delta hours minus 6 and minutes is equal to minus 13. So our offset is 6 hours 39 minutes. And here you can see that it is coming as 6 hours 39 minutes upon usage. The optional argument time spec specifies the excuse me. The optional argument time spec specifies the number of additional components of the time to include. The default is auto. It can be one of the following: auto, same as seconds. If microseconds is 0, same as microseconds otherwise. Hours, include the hour in the 2-digit HH format. Minute, include hour and minute in HHMM format. Seconds, include hour, minute, and second in HHMM/SS format. Milliseconds, include full time but truncate fractional second part to milliseconds. And then we have microseconds, include full time with HHMMSS.FF format. Excluded time components are truncated, not rounded. Value error will be raised on an invalid time spec argument. So here we give time spec is equal to minutes, and here we give microseconds. Then we have __str__ function, which is equivalent to printing it using ISO format with empty space argument. Then we have ctime, which returns a string representing date and time. So here you see we have the name of the weekday and name of the month. The output string will not include time zone information regardless of whether the input is aware or naive. D.ctime is equivalent to time.ctime, time.maketime, d.time tuple. On platforms where the native C ctime function, which time.ctime invokes but which date time.ctime does not invoke, conforms to the C standard. Then we have strftime, return a string representing the date and time controlled by an explicit format string. And we will see this a bit in format specifier. Then we have format. So same as datetime strftime, this makes it possible to specify a format string for a datetime object. So they both take the format string as an argument. Oops. So where were we? Sorry, I misclicked here and there. Okay, so here we were. So both take string as an argument. Now we have some examples. We import datetime, and then we create a date, we create a time, and we combine both of them. So we get a datetime object. Then we use datetime.now. So this was invoked on 12th of June 2007. Okay. Give me a moment. This was hour or minute or whatever. This was 14th. Uh, I forgot this. This should be month, right? And this should be the day because that's how ISO works. And then we have datetime.strp time. So we print this according to this format. And when you do my date time, you get this. Then we have time tuple, and you print each thing. So year, month, day, hour, minute, second, week, day, number of days since 1st January, and BST. Then we have it in ISO format, that is ISO year, week, and weekday. And we format it according to strft time. So this is the format string. We will see the meaning of all this very soon. And this is the format invocation of the function. The example below defines a TZ info subclass capturing time zone information for Kabul, Afghanistan, which used a +4 UTC until 1945 and then a +430 UTC thereafter. So you see, if you see this code, we have the class Kabul TZ, which take TZ info argument. Then we have UTC move date, which is 31st of December 1944, and this is evening 8 o'clock, and the time zone was UTC. Now, when the year is less than 1945, time delta hours was 4. So 8 was chosen because offset was 4. So at that time, UTC was midnight. And then when it becomes 1945, okay, and it takes the time tuple, which is less than 1945, first of 1945, 1st of January, 30 minutes past midnight. In that case, it returns time delta with hours 4 minutes 30 when fold is true and otherwise 0, or else it returns time delta with 4 minutes 30 seconds. Then we have from UTC and everything. The interesting part was this one, okay, and it does other things, and finally it shifts the clock. So that is how you shift the clock when there is daylight saving time is in picture. So here is the uses of this, and so you see that how initially offset was 4 o'clock and then later it was 4:30. How this object was created with the time zone UTC. This was created with UTC D3 and D2. D2 was created with time zone TZ1, where TZ1 was Kabul TZ, and we see that D2 is equal to D3. Now we have time objects. Let me see how much is there in time object. Okay, we will cover the time object and then we will wrap it. There is not much in time object. A time object represents a local time of day independent of any particular day or subject to adjustment via a TZ info object. So it takes hour, minute, seconds, microsecond, and TZ info along with fold. All arguments are optional. TZ info may be none or an instance of a TZ info subclass. The remaining arguments must be integers in the following range. Hours obviously between 0 and 24, minutes between 0 and 60, second between 0 and 60, microseconds between 0 and 1 million, and fold is either 0 or 1. If an argument outside those ranges is given, value error is raised. All default to 0 except TZ info, which defaults to null. We have class attributes min, so this will give us the earliest representable time, that is 0000, the default constructor invocation. Then we have max, which is 23, 59, 59, and then 1 million. Resolution is not 1 million, 999,999. Then we have resolution, the smallest possible difference between two non-equal time objects, which is time delta microseconds, is equal to 1. Although note that arithmetic on time objects is not supported. Then we have instance attributes. Those are hour, minute, seconds, microsecond, TZ info, and fold. We have already seen what fold is. Time objects support equality and order comparison, where A is considered less than B when A precedes B in time. Naive and aware time objects are never equal. Order comparison between naive and aware time objects raises type error. So this is common stuff everywhere. If both components are aware and have the same tz info attribute, the tz info and fold attributes are ignored and the base times are compared. If both components are aware and have different tz info attributes, the components are first adjusted by subtracting their UTC offsets obtained from self.UTC offset. In Boolean context, a time object is always considered to be true. Then we have other constructors. One is from ISO format. Return a time corresponding to a time string in any valid ISO 8601 format with the following exceptions. Time zone offsets may have fractional seconds. The leading T normally required in cases where there may be ambiguity between a date and a time is not required. Fractional seconds may have any number of digits. Anything beyond 6 will be truncated. Fractional hours and minutes are not supported. So we have several examples of this function. We have HHMMSS, then we have T, then we have T without colon, and then we have microseconds, and then we have comma before microseconds, then we have time zone information, and then we have UTC zone, then we have another UTC zone. So then we have strp time, which takes a date string and a format, return a time corresponding to date string passed according to format. If format does not contain microseconds or time zone information, this is equivalent to time star time.strp time date string format equals 6. Value error is raised if the string format cannot be passed by time.strp time or if it returns a value which is not a time tuple. See also, we will look at this in below. Then we have replace, just like date time replace, it takes hour, minute, second, microsecond, and tz info, fold is 0. And by default, it will use the self values. Okay. And it is similar to datetime.replace, and time objects are also supported by dynamic function copy.replace. Then we have as a format, time spec is equal to auto. So we have several possible variations. So this is when microseconds is not 0 and it is omitted if microseconds is 0. Then we have plus this if UTC offset does not return none. And then we have this if microsecond is 0 and UTC offset does not return none. The optional argument time spec specifies the number of additional components of the time to include. The default is auto. It can be one of the following things. It can be hours, minutes, seconds, milliseconds, and so on, just like datetime object we have studied. So similarly, we can construct objects. So here we have a time spec minutes. Then we construct object here, microseconds and auto. So these are invoked on the instance. Then we have str, which is equivalent to ISO format. We have strft time, which will format with the format string. We have format, which allows the invocation of format method on this. Then we have UTC offset. If tz info is none, returns none, else returns self.tzinfo.utc offset none, and raises an exception if the latter does not return none or a time delta object with magnitude less than 1 day. Then we have DST. If tz info is none, returns none, else returns self.tzinfo.dst none, and raises an exception if the latter does not return none or a time delta object with magnitude less than 1 day. Then we have tz name. If tz info is none, returns none, else returns self.tzinfo.tzname none, or raises an exception if the latter does not return none or a string object. So here we have tz1 where we have custom offset where time delta is 1 hour. Then we have DST where time delta is 0. Then we have tz name, which gives a string plus 1 hour. And then in the rep we just print the class name. So we see the examples. We construct time where it is after noon and 10 minutes past 12, 10 minutes 30 seconds past 12. tz info is tz1. So see, it tells us the tz info is tz1, and in ISO format it is 01 colon 00. Then in DST time delta is 0. STRFT time you will see, and this is the format string example. H and M gives you hour and minute, S gives you seconds, and Z gives you time zone info. So with this, I think it is about time we stop here. In the next video, we will look at TZ info, time zone, STRFT time, and STRP time behavior. Okay. So I hope that you are enjoying this series of read-throughs of Python standard library and finding it useful and insightful, because people generally look up standard library when they need something. Okay. In general, people don't look at the documentation. So if you have any comments or you want to have videos on certain topics or anything you want to say, make use of comment box. Okay. Give me feedback whether you like the video or you dislike. Why do you like the video? What do you dislike? So that I can improve and I can make adjustments in making videos. If you don't want read-throughs at all, let me know that it is not required, and we will continue with TZ info in the next video. I will end this video here, and I thank you for watching the video and spending your valuable time on this. So we will meet again, because we rotate on C++, Java, Python, and Rust. So approximately 4 days from now, we will meet again and we will continue with info objects. Till then, I will take my leave. You take care and keep learning. Thank you. Have a nice day.